Hello, this is your professor, Doug Healthbell. We're doing our Unit 1 Outcome 1 notes, so we're getting started here. Just a reminder, these notes are posted in MyLab and D2L, in MyLab and D2L, so you can refer back to these afterwards. The completed notes will be posted, so that you can go back and refer to those. So hopefully you can use that as a tool to help yourself make sure you understand what we covered. So I'm going to start off this first outcome. We're going to talk about plotting points, graphing equations, find the distance between 2 points, the midpoint of a line segment between 2 points. So that's what we're covering this first outcome. So first off, just plotting points. We're going to plot on the coordinate graph or the Cartesian graph, just different names for the same thing, also called the 2D plane. So it's the XY plane where X is the horizontal axis, Y is the vertical axis. We call this point right here in the middle the origin. When we graph, we always graph starting from the origin. So this point 2, 3, we would graph by counting. We always count the run before we jump. That's why I was telling middle school, you run before you jump. So we'd count 2 over for the x direction and 3 up. And we plot the point A right there. That would be the point 2, 3. Always do the x direction first and the y direction second when you plot points. So points are always in that order. To do negatives, of course, you just go left if you're going in the x direction. You go down if you're doing the y direction. So point -3, 2. You plot right here because we do -3 on the left and then 2 up, and that would be the point B. Last point here we have 0, -4. Since the first value is 0, we're not going to move left or right. We're going to stay in the middle. That 0 just keep us in the middle, and the -4 would bring it down to the point right here. This would be the point 0, -4 because we moved 0 in the x direction and 4 down in the y direction. So that would be the point C. So you should be ready to graph points, something you've probably seen before. You should be able to also read points off the graph. So if we give you a point on a graph, you should be able to read it off. They're not always going to fall nicely in the intersections of the lines where they're whole numbers. So a point like D here, it is a -4 over. So in the left-right direction we are -4, but here you can see it's actually about between 2 and 3. So we'd say the vertical, the y direction is about -2.5. So we'd say this value is -4, -2.5, something like that. You kind of have to estimate the best you can with a graph point like that. You can't do any better than just kind of a guess because we're looking at where it is. And all of these points should always be graphed with these parentheses that tell us this is an ordered pair. This is a location on your coordinate plane. So the D is the point in the -4, -2.5. E here would be 5 to the right, so we'll go 5 and down 1.5, so that would be the point 5, -1.5. So we'll go 5, -1.5. Again, negative because we're going down, we use positive for up. Don't forget your parentheses. So that's just, locating points on there, graphing points on there, something you've probably seen before. A lot of times we work with graphs, we work with equations. So equations that have both an x and a y in them, their solutions will be ordered pairs like this. There'll be 2 values, one for x, one for y, always the x first. It's alphabetical order, if you never noticed that, it's alphabetical order. So the x, y are the solution. They want to check here if 2, 3 is the solution for this equation. So if we plug in 2 for x and 3 for y, we can see if it's true. Remember, equations have a solution when they are true. So we're looking to see if this equation is true. So plugging in 3 for y, we get 6 times 3. Remember, when you have a number next to a letter, it means multiplication. 3 times x, so x is 2. So we have -3 times 2. Again, I'm going to put parentheses here for multiplication now because they're all numbers. When you have a number next to a letter, it's multiplication. And we're going to see if that does equal 12. If it's true, then yes, this is a solution. If it's not true, then we know it's not a solution. So 6 times 3 is 18. 3 times 2 is 6. 18 minus 6 is 12. And it does check out, right? 18 minus 6 is 12. So yes, 2, 3 is a solution. What this means is if you created a graph of this equation, if you made a line that goes with it, this would be one of the points on that line. That's what we do when we graph equations, when we graph lines. We actually are graphing all the solutions to that equation on this graph. So if you want to draw this line on this graph, one of the points would be the point 2, 3. That would be one of the solutions. Now we also want to, on this one, we want to find the x and y intercepts. Now, intercepts are important. Intercepts are where you cross the x-axis or the y-axis. If I drew this line, I would want to find out where is it going to cross this x-axis and where is it going to cross this y-axis. Those are important points. They're usually nice things to find. The way we do this, first, if I want to find the x-intercept, the way we do that, we're figuring out where the point is on this x line. We know that if we're on the x line, the x-axis, then the y value has to be 0. You have to be in the middle, up and down. So what we do is we actually just make the y value 0, and that will tell us what the x-intercept is. To find the x-intercept, we set y equal to 0. So if we make the y 0 in this equation, we can go back and find the x-intercept. So I'm going to make y 0, so I get 6 times 0, I just made y 0, minus 3x equals 12. And then we'll solve this equation for x. First off, 6 times 0 is 0. That's nothing, so we don't have to worry about that anymore because 0 just isn't going to affect the equation. So we end up with minus 3x equals 12. Remember, to undo multiplication in an equation, we always divide. To undo multiplication, so I'm going to divide both sides by the same amount. I'm going to divide by negative 3. That way, if the negative 3 multiplied and the negative 3 divided, cancel. Now, if you do the same thing to both sides, remember with equations, you always have to do the same thing on both sides to make the equation stay equal. So here, the 3 and the minus, they all cancel. We're just left with the x. Over here, we have 12 divided by 3 is 4. And don't forget that a positive divided by a negative is always a negative. So we get negative 4. So that's the x-intercept. We can think of this as a point. This would be the point, negative 4, because remember the x comes first, so negative 4. And 0, because we made the y 0. So that is the point for this x-intercept. So it has an x-intercept from negative 4, 0. If I graph this one, I'm going to graph this in green on here. So we're going to go negative 4 and 0. I'm going to say that's where it would cross the x-intercept. That line would cross right there. That would be the x-intercept. Okay, let's find the y-intercept. Now to find the y-intercept, we're going to set the x equal to 0. So to find the y-intercept, we set x equals 0. That means if we're on this y-axis, we're in the middle line that goes up and down, we need our x value to be 0 because that puts us in the middle horizontally. So the y-intercepts are always going to have an x of 0. So we set x equals 0, so we're going to take the same equation, 6y minus 3 times 0 equals 12. I'm going to solve for y. And that will give us the y-intercept. First off, again, 3 times 0 is 0. That's nothing. Subtracting nothing, we don't have to worry about it. So we take that out. So we're left with 6y equals 12. Divide to undo some multiplication. So we're going to divide both sides by 6. Get rid of this thing. So undoing multiplication with division. And we get y equals, what 12 divided by 6 is 2. So the y-intercept is 2. Again, a point for this. The point, well, now the x is 0, so put 0 for x. And the y is 2, and that would be the point. So if I graph that point, that's the y-intercept point. It means I go over 0, up 2, so that 2 is the y-intercept. That's our y-intercept. Now, if I draw with a nice straight line, hopefully I'll just try and draw it by hand, but hopefully I'm drawing it fairly straight. It should look like this. That should be the equation, the line. That's that 6y minus 3x equals 12. That's what it looks like. Since we knew 2, 3 was a solution, we should know that if we go 2, 3, right there, it's actually that same a we already had. That's the point 2, 3, should be on that line. So when you graph lines, you're actually just graphing a whole set of solutions. Every point on this line is a solution. And again, we like these x-intercepts and these y-intercepts. They're important points to know about. And they're also pretty easy to find. Any kind of equation you have that you can graph, you can always go back and solve it by setting, find the x-intercepts and the y-intercepts. You can always find the x-intercepts and y-intercepts by setting the opposite letter equal to 0. So I find the x-intercept by setting y equals 0, and the y-intercept setting x equals 0. And we'll kind of see that come up later on in the semester when we get to more complex equations. It's always nice to be able to go back and find these intercepts by just setting the opposite letters equal to 0, and you can get those intercepts. Okay, that's the first part. Next part, we're going to talk about the distance formula. So the distance formula is just the way to find the distance, so the length, between 2 points. If I call the first point x1, y1, we're just using x and y because they're generic. We'll call them at 1, so we use the subscript 1. And the second point, x2, y2. So there we go again, x and y, but we're just labeling it with a 2. If we want to find the distance between these two, what we actually use is we actually use Pythagorean's theorem. You probably remember back in school, geometry class, you learned a squared plus b squared equals c squared. That's that Pythagorean theorem. Well, what we do is we say we can find this length, the long side, remember it's always the C side, this is the hypotenuse side of this square right triangle. If we take the two shorter sides and we square them, add them together, and then since we don't want the final answer to be squared, we'll actually go back and we'll square root it. So we'll actually do this version where we square root both sides. Because when you square the C squared, you just get the C. And so that's actually the equation. That's what this distance formula is up here. It's just taking the length of this bottom side, where you take the x's and subtract them to find out how long this piece. So you subtract to find the length on the bottom, and square it. Take the up and down length, subtract these two to find this distance, square it, add those together, and then square root the whole thing. And that's where this distance formula comes from. Now, you don't have to worry too much about having this memorized because this is on the formula sheet. So a lot of these formulas like this, I'm not really worried about you memorizing them because you can Google these in real life, right? So on the test, I'll provide the formula. In real life, if you ever need to find the distance between 2 points, you just Google what's the distance formula, and this will come up right away. So I'm not really worried about memorizing formulas. That's not really important to math class. But you do need to know how to use the formula. So I give you a couple points. I'm going to want you to plug into this equation, find the distance by simplifying that formula. So it is on the formula sheet. And so when you take your tests, you'll have a formula sheet. And this is one of the things that'll be on there for you. Okay, so let's find the distance between the 2 points, 2, 3, and 2, 10. Now it doesn't matter which one you call x1, y1, x2, y2. Distance works whether go left to right or right to left. So that's not really important. You just want to be consistent. So if I call the first one the 1 point, the x1, y1, I don't want to call one of them x1 and the other one y2. That's where you'd be in trouble. So this is my first one, and this one has to be both the second point. So x2, y2. So now when I go to fill this in, I know that these 2 and 3 are going to go in the first parts, and then the 2, 10 are going, or sorry, 2, 3 are going to go in the 1's parts, and 2, 10 are going to go in the 2's parts. So plugging into that equation up here, we have the distance is equal to that big old square root. I never make mine big enough. It's funny how I always run out of room. We'll probably extend it here so we watch. All right, and then I take my x's and subtract them. So I'm going to take my x2, which is 2, and subtract my x1, which is also 2. I'll subtract those and I'll square them, because it's parentheses squared, plus the other parentheses I'm going to have y2, which is 10, minus y1, so minus y1, which is 3, at quantity squared. See, I told you, I never have enough room. I kind of like to put a little tell here at the end just to tell people it's done. It's kind of a weird thing I do. Okay, so that's what's in the square root. Now we're just going to simplify this because it'll give us the distance once we simplify this down a little bit. First thing, we're going to go ahead and do subtraction. You always start inside parentheses. So 2 minus 2 is 0. This one actually is going to be pretty easy because 0 squared is still 0. So that one's not going to be anything on that part. The other part over here, we have 10 minus 3, which is 7. So we get 7 squared, still under the square root. Now I don't have to worry about the front part because 0 is nothing, so we're just going to drop that. So we just have 7 squared. 7 squared gives me 49, and the square root of 49 is 7. So this distance is actually 7. And if you actually thought too much about what these points are, you probably could have done this without even using the distance formula. Because if you notice, if I draw a little graph real quick, if I make a little graph here and I think, okay, go to the right 2, so 1, 2. The first one goes up 3, 1, 2, 3, there's a point there. The next one goes over 2 and up 10, so 4, 5, 6, 7, 8, 9, 10. Make that longer. I have a point right here, and you can see that these are directly above each other. And this length here is just going to be 7, right? Because you go from 2, 3 to 2, 10, you can find that length. So anytime your points are directly above each other like this, or if they're directly horizontal side to side, they're going left to right, you can just find the distance without the formula. The formula is most useful when you have this kind of diagonal situation like up here. So let's try another problem. This one is going to be a little more complicated because now it's not going to work out to a nice even number because these points aren't lined up. We don't have them both 2 to the left or 2 to the right. 9 and 15 don't match, 4 and 1 don't match. So this one, the distance formula will be a lot more necessary. But yeah, 7 was our answer on that first one. So, okay, again, we'll use our formula. So the distance equals, again, x2 minus x1 squared, y2 minus y1 squared. So x2 is going to be our 15, that's our x2, x1 is going to be our 9, so we subtract those, so we got 15 minus 9 squared, and then we're going to do our y, so y2 minus y1, right? y2 minus y1 squared. So we got y2, which is 15, minus the y1, which is 4, we square that amount. So yeah, I always make these too long, or too short. I always have to lengthen them. Okay, so I'm going to subtract first, like always. So I'm going to subtract these two. 15 minus 9 gives me 6. 15 minus 4 gives me 11. Both of those are still squared, so I'm going to square them. And still the square root on there. 6 squared is 36. 11 squared is 121. One of those weird things you memorized as a math teacher. But yeah, 11 squared is 121. We're still going to add those and still going to square root those. So 36 plus 121, that gives me 157. So that's square root 157. Now, you do have to be careful when you're solving, when you're working with square roots in this course. We're only going to take square roots like this if they won't simplify. So you always got to double check real quick. If there's any numbers that divide into your square root, you should do those, simplify that square root. So things like if I could divide it by a 4, a 9, a 16, 25, those are all perfect squares. I'd want to do that. But I think 157 in this case doesn't actually simplify. So we're actually going to just leave that one as is. It's not a nice number that can be broken up, simplified. A little kind of side note, if you did have a problem like this and you got done, you had an answer like square root of 20. You wouldn't want to leave it like that. My math lab wouldn't accept it. You'd probably just point something. You wouldn't point on something on exam because that's not a simplified root. So just a reminder, simplified roots, we're always taking these and we're breaking them down into parts that will square root and parts that won't square root. So something like 20, you can break it up into 4 times 5 because 4 times 5 gives us 20. And you can square root it separately. This is what we call simplifying roots. And I always try to break into nice numbers like 4 that will square root. So I'm going to look for things like 4, 9, 16, 25 that will divide out of my number. 4 divides out of 20, and you can square root 4 to get a 2. And then 5 you can't do anything with because 5 doesn't square root. It's not anything to itself except for 5 times 1 gives you 5. That's it. So we would leave that as a square root of 5. But this would be what we'd put. If we got an answer like square root of 20, we would simplify it because this would be simplified. And this is what my math lab's going to tell you. If you get a problem, you get an answer like square root of 20, and you leave it as square root of 20, they're going to count it wrong. But if you write it as 2 root 5, they're going to say, yeah, that's simplified. That's a good answer. Now again, 157 we kind of got lucky with. It doesn't simplify any more than that. So that one is just done. If it doesn't have any nice numbers like 9 or 16 or 25 that come out of it, those perfect squares is what we're looking for. None of those divide out of it, then we just leave it like that. So that one is done. We can move on to the next part. Okay, so now we did distance. Now we're going to talk about midpoint. So midpoint is the point halfway between 2 points. So I have point x1, y1, and x2, y2. We can find the point halfway between using this fancy formula. Now, I'll just warn you right now, this formula, I never really use it. If you look at it, you kind of start to realize what's going on here. You notice that here, they're just taking the x numbers, adding together and dividing by 2. Well, this is just the same thing as averaging. Remember average when you add up all the numbers and divide by how many there are? Well, since I only have 2 numbers, if I add those up and divide by 2, I'm just averaging the numbers. So this formula, it's on your formula sheet. So again, this is on the formula sheet. So you don't have to memorize it. But I'll just tell you right now, I don't actually ever use this. I never use this formula because I just remember if I want to find the midpoint, it is the average of the points. So if I want to find the average of 3 and 5, I take 3 and 5, I add them up, and then I divide by 2. That's what I do. That's the average of these two numbers. So you average numbers by adding divided by 2. So 3 plus 5 gives me 8. So I get 8 over 2, and 8 over 2 simplifies to 4. So that's the first part. To do the other part, I take my -4 and my 8, take the y values. That was x1, x2 that we did. Now we're doing y1, y2. And we take -4 plus 8, and we'd add those up and divide by 2. Well, -4 plus 8 is 4. 4 over 2 gives me 2. So that is the midpoint. I'll just put parentheses around this just so you can see how we got this. But this is our answer right here. This is the midpoint. And again, it's halfway between. It is literally halfway between. You think about 3 and 5. What's halfway between? Well, 4 is halfway between 3 and 5. -4 and 8 is not quite so obvious, but if you think a number line, 2 is going to be kind of halfway between -4 and 8 because it's a little bit closer to 8 on the positive side, but it's actually 6 away from 8 and 6 away from -4. So this is halfway between. If you graphed all 3 points, this would be literally halfway between the 2 points. So that's midpoint. Midpoint's all about taking the 2 numbers, adding them up, dividing by 2, and getting the average. That's midpoint. So we'll try one more. Let's try the midpoint for this next one. 2, -4, and 5, 3. But again, I'm just going to take the x values, 2 and 5, add them up and divide by 2. And take the y values, -4 and 3, so -4 plus 3, add them up and divide by 2. And that'll give us our midpoint. So first off, 2 plus 5 is 7, so I get 7 over 2. -4 plus 3, I have more negative than I do positive, so I get a -1 over 2. And then this doesn't actually simplify any further. You can't divide 7 by 2, not nicely. So we'll leave it. We like these improper fractions. I always have students ask about mixed numbers. We don't really like to work with mixed numbers in algebra because mixed numbers, where you break off a whole part, are kind of more complicated to work with and make things harder in algebra. So we'll just leave it just like this. And this is how my math that we want you to answer the question. We want these fractions typed in. They prefer fractions, not decimals. So that's it for midpoint. Midpoint's not really that big a deal. Again, like I said, you're just averaging the points. Just add them up, divide by 2. The last part of the section is circles. We are going to deal with circles because circles are a great thing to work with, especially with midpoint and the distance formula, which you'll see in a minute. So when you work with a circle, remember the circle always has a center, right? The center of your circle is in the middle. In algebra, we like to label the circle HK. So we call the point that is the circle the point HK. So you'll see HK are the x and y values of your center. Remember that circles have a radius. The radius r, so r is going to be your radius. It is the distance from the center to any point on the circle. So you could draw a radius here, you could draw a radius, over here, you could draw a radius up there. Any point on the circle is that far away from the middle. So every point on the circle is r away from the center, hk. Now, if you know this information, the radius, h and k, the center of the circle, you can actually write the equation of a circle, and this is how we write it. Where we take x minus h, where h is the center of the circle, is the x value of the center of the circle, squared, plus y minus k, again that's the k that's from the center, that quantity squared equals the radius squared. So if you know this information, if you know the center of a circle and the radius of a circle, it's really easy to get the equation. Again, this is on your formula sheet. So I'll probably forget to tell you some point, but you can always look at the formula sheet because it's in my Math Lab in D2L right now. You can go and pull it up for the Unit 1 test. That way you can kind of get an idea of what's going to be on the test. I highly recommend when you're doing the homework and quizzes that you look at that formula sheet and use that so that you kind of get familiar with it. And then when you're going to the test, you already know what's on there. Okay, so we have the center, we have the radius. They want us to write the standard form of the equation. So they want us to write an equation that looks like this. The x and the y are always going to stay in there because when you're writing equations for graphs, you always have to have an x and a y in there, so they'll be in there. We're just going to replace the h, the k, and the r, the radius. Remember that the center gives us h and k, and the radius gives us r. So they're just telling you what these numbers are and to put them in this formula. So we have x minus h, so x minus 1, that quantity squared, plus y minus k, well k is 3, so y minus 3. That quantity squared equals the radius 5 squared. Now this is standard form, but you need to be careful. The Math Lab doesn't like you to do something like 5 squared where you can really easily just calculate that value. They don't like you to leave it like that. So something where you can do 5 times itself and get 25, they won't want you to do that. So the answer here would actually be 25 on there, not 5 squared. So if you're going to type this in, if you're doing your homework in my Math Lab or doing a quiz, you want to make sure you always have the appropriate form of the answer. And so that's what they're going to look for. They're going to look for an answer that looks like this, because we all know that 5 squared is 25, and that's just a better way to write it. So that's going to be the answer. So that's the standard form of the circle. If you have the center and the radius, you can always write this equation of the circle. So this is the equation that gives you the circle as a center at 1, 3, and a radius at 5. Okay, let's work a little bit more with that circle. We're going to do one more just like we did. They're going to give us the center and the radius and ask us to write the equation again. So we're writing the equation of the circle. So again, remember the center gives us h and k. The radius is r, and we're just putting them in this equation. So start off with x minus h, which is a -3. Now when you subtract a negative, remember that when you subtract a negative, you always add the opposite. We learned this, back when we first learned how to work with negative numbers, that instead of subtracting a negative number, we actually add the opposite. So instead of subtracting a -3, we're going to add a +3. So we're going to turn this into +3. It's kind of a double negative, right? There's a negative in the equation to start with. There's a negative on the 3. When you put two negatives together, you get a positive. A double negative makes a positive. That's why we get x plus 3 squared here. And then the other equation will have y minus k. And since k is a +2, it's not going to change the sign. It's going to stay y minus 2. It all has to do with these negatives that are built into the standard form of the circle. So if it's negative like this, it means you're using a positive number like 2. But if it changes to a plus, it's because you had a second negative here that changed it back to a plus. So watch out for that when you're working with circles, whether they have the plus or the minus. The minus is for the positive numbers. The plus is actually for the negative numbers because of the double negative. Okay, this equals the radius, which is square root of 3. But don't forget the radius is squared. So we get the square root of 3 squared. Now hopefully you remember that square roots and squares are opposites. Remember that the square root here is saying, what am I multiplying times itself? And the square says you're multiplying this thing times itself. So we're actually taking this 3 and multiplying by itself. That's what the square says. And the square root asks, what are you multiplying by itself? Well, the answer is 3. So when you have a square root and a square like this, the square root and the square cancel, and you just get the answer 3. So again, if you put in square root of 3 squared like this, and math would count that wrong, you get it wrong on the test, you need to simplify it down to just a 3 like this. So we have x plus 3 squared plus y minus 2 squared, and that's the answer I'd be looking for, my math I would be looking for. That's the appropriate answer. That has the radius squared like it should be, has both parts, has all the x's and y's. Again, these equations should always have an x and y in them, so you can go ahead and graph this later if you need to. Okay, this was going where we had the information, we wanted to write the equation. Sometimes they'll give you the equation and then go ask the information. So here we go, we have the equation of a circle, and we want to use this to find the center and the radius. So I got to think about what's given here. Now this one looks a little weird because it's x squared by itself. That x squared doesn't have a parentheses. It's missing the parentheses. And why is that? Well, that's because when you subtract nothing, you don't need a parentheses because subtracting nothing is pointless. So this x squared is actually the same as having x minus 0 squared. So whenever you see that, where you see this missing parentheses, when you have both the x and the y in a circle equation like this, if there's no parentheses, it's because they were subtracting 0. And I said, well, I'm not going to write x minus 0 because that's silly, because I can just write that as x, because I know that x minus 0 is x. So when they do that, it's because the part of the circle is centered at 0. So if I think about the equation this way, now it kind of helps me see that the center here for the circle is actually hk, the center. H is 0, and k here is actually negative 2. Don't forget, remember that this is y minus negative 2. A double negative here is what made it that positive, because there's a negative in the equation and a negative on my 2. So that's the center of the circle. So this circle is centered at 0, negative 2. The radius here, well, the radius squared is 9, right? This is the radius squared. So the radius is going to be the square root of that. So what's the square root of 9? Well, that's 3. So if I square root the radius squared, I get the radius. So 3 is the radius, just like this is the center. Okay, so now we know the circle's center, we know the radius. When you're working in homework, my math app is a really great tool. It's got graphing tools where you can graph a circle, and really all you need to know about the circle is the center and the radius. You put that information in, my math app will let you graph it. I'm going to go ahead and graph it by hand just so we can see what it looks like. It's going to be a little messy because I don't have a computer to graph it for me, but I can notice that the center here will be at 0, negative 2. It'll be 1, 0, and then jump down negative 2. That's the center of my circle. And then I need to use my radius to get some other points. Now, I can't count diagonally, because diagonally this isn't 1. It's like 1 and a little bit. But I can count horizontally or vertically. So I'm going to go horizontal, 1, 2, 3, and I'm going to say there's a point right there. I can go the other way. I can go left, 1, 2, 3. There could be a point right there. Go up, there's a point, 1, 2, 3. There's a point right there. Go down, 1, 2, 3. There's a point right there. So that gives me some 4 points to graph. So I know the circle is going to go through those 4 points. Since I'm doing this just quick and dirty with a pen, not having a computer do it, let me go ahead and just try and draw a circle around these points, which no promises. It won't be perfect because it's a freehand circle. But again, my math app will kind of do that part for you, which is kind of nice. You just have to identify the center, identify that radius, which is 3. So the center was that point 0, negative 2. And the radius was that point, that distance, that length here of 3. So if you have an equation like this of a circle, you can draw the circle pretty easily. You just have to identify what the center is, what the 2 points of the center are, and the radius. We're going to do one more like this. The only difference here is now they didn't give us the equation. So this one says, instead of find the equation, it says, or instead of giving us the equation, it says to find the equation ourselves, and then we'll graph it. So we actually have to get the equation ourselves. And it tells us that we have a circle whose diameter is endpoints negative 3, negative 1, and 5, negative 1. Remember, diameter for circles is not the radius, it's not the middle to the end. The diameter is the whole length across. So for a circle, the diameter is the entire length across the circle. So when they tell us that negative 3, negative 1, and 5, negative 1 are points on the circle, these are endpoints of a diameter, they're telling us these are 2 points on my circle. So over here, negative 3, negative 1, this is a point on my circle. And 5, negative 1s, go over here to 5, negative 1, this is a point on my circle. So I know these are 2 points on my circle. And I can see that I could draw a nice line between them, and that would be a diameter of the circle. The circle would be, that would go all the way across the circle, just like a line here would go all the way across the circle. Okay, so what do we need to do? Well, first off, we need to figure out what the center of the circle is. Now, remember that, if you have a line, you want to find the middle, you can use midpoint. You have 2 points, you want to find the middle, you can use midpoint. So here, to find the center, I'm going to find the midpoint between these 2 points. So I'm just going to use that to figure out what the center is. So to find the center, we're going to use midpoint. And the midpoint said just find the average of the 2 points. I'm going to take the x's, negative 3 and 5, add those up and divide by 2. Now find the center there, the midpoint. And then I'm going to find the midpoint of the y's. Here I have negative 1 and negative 1. So add those up, negative 1 plus negative 1. Find the midpoint of those, the middle of those, and that'll give me my midpoint. So negative 3 plus 5 is 2. 2 over 2 is 1. So that's our first coordinate of my center. And the center is going to be 1 over. And then the next one, negative 1 plus negative 1 is negative 2 over 2. And then you take a 2 divided by 2, you get 1. And a negative divided by positive gives me a negative. So the center here is at 1, negative 1. That's our center. So h is 1, k is negative 1. So I go over to 1, negative 1, and that would be the center of the circle. And that makes sense. You can see how there's 4 here, there's 4 here. In fact, that's enough to figure out the radius on this problem. So if I wanted to find the radius of the circle, I could look at the radius, the distance here, and find out what that radius is. Now, just because sometimes this isn't going to be that easy, I'm going to show you real quick how to do this with the distance formula. But if you have a nice easy one like this, you could just measure the radius. But some problems won't be that easy. So just in case for the homework, I'm going to show you how I do it without. Now what I would do is I'd probably take one of these points in the center and find that distance. So I'm going to pick a point. I'll pick the first point, the negative 3, negative 1. It doesn't matter which point you pick, but to find the distance, you have to use one of those points. So find the distance, and then use that distance formula, where we have that d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, and find that distance. So here I would take my x2, so that's going to be my second one. I'll go ahead and use this as my second one. So we'll call this x2, y2, so my negative 3, minus my x1, so we'll call the center my x1, so minus 1, square that. The y's, I'm going to do the negative 1 minus this negative 1, and square that, and then square root the whole thing. So I'm going to simplify this a little bit. Negative 3 minus 1 is going to give me a negative 4. And you square the negative, you always pick a positive, so I get positive, and 4 squared is 16. So that's doing 2 steps there, just because I'm running out of room, so I'm going to expedite a little bit. Here I have negative 1 minus a negative 1. Remember, a double negative, though, is a plus. So a double negative turns that into adding. So negative 1 plus 1, those cancel. That just becomes 0 squared. So I get 16 plus 0 squared, which is nothing, right? 0 squared is still 0. So I really don't need to worry about this part because it cancels. So I just have the square root of 16. My final answer ends up being 4, which is what we set up here, right? We said the distance here, the radius is 4, and that's correct. That was our distance. Again, it's not always going to be quite this easy. I'm sure it's an easy problem for the notes, but in the homework you might get a problem where you might not be able to just measure this radius. Maybe the endpoints will be diagonal, and you'll have to figure out what this distance is. But it always works to take the endpoint in the center and find the distance between those using that distance formula, and that's one way to get the distance there. Okay, so we wanted to graph the circle. Well, we found the center, the graph 2 of the endpoints. We can go ahead and graph a few more using this distance 4. So we'll have 1, 2, 3, 4, up, 1, 2, 3, 4. And that gives me 4 points to graph it. Again, on your homework, you just need the center here and the radius here. This 4 would be my radius. And that would give you enough information. So that, okay, not very pretty, but it is our circle, and that's a graph. And so that's our first section. So first section, dealing with circles. Remember, if you have endpoints, let's do ends of a circle. You can find the midpoint to find the center, or you can use distance to find the distance from the center to an endpoint to find the radius. If they give you an equation, you should be able to draw a circle because you can identify the center and the radius. And then again, if they give you a center and radius, you should be able to write the equation for the circle. Going backwards a little bit, recapping, you should be able to find the midpoint of 2 points. You should find the distance between 2 points using that distance formula that we talked about. And then the first thing, you should be able to find x and y intercepts, check and see if there's a solution, and graph or read points off a graph. We'll get more into graphing later on this semester. Here in this first unit, we'll get into more straight line graphing. So that's just kind of our introduction to it. So hopefully that helps you out a lot, and you're ready to go on with that first homework.